everyone. Again, welcome to Incredible Learning Experience Jnana Learning. So we are continuing with the lecture on electromagnetics, and this is lecture 3, Curl and Stokes Theorem. So if you are watching my lecture for the first time, please do subscribe our channel Jnana Learning for more updates. So we start. So in this lecture we are discussing about the curl and Stokes theorem. So in previous lecture we have discussed divergence. So similar to that, curl is also an important parameter regarding vector field. It is a circulation of a vector field around a closed path, and it is defined as the integral, closed integral over L A dot dl. So see here in this picture, it is shown a closed loop is shown, or a closed path L, and in that here shown the vector field A. Now this is a closed path L and this is a vector field A. So the circulation of this particular vector field around this closed path, that is A, B, C, it is defined as the curl of the vector field. Now see, the curl, it is actually an axial or rotational vector whose magnitude is the maximum circulation of A per unit area. And here we take the area tends to 0 in order to get the direction, and here the direction is considered as the normal direction of the area where the area is oriented so as to make the circulation maximum. So curl, it is the axial or rotational vector whose magnitude is the maximum circulation of that particular vector per unit area, as we consider the area tends to 0. Now it is defined as curl of A is equal to del cross A, that is limit delta S tends to 0, that we are defined here, that is area tends to 0, that is delta S tends to 0, closed integral over L A dot dl by delta S, and here An, it is the unit vector along that the direction, and the maximum value is considered, that is delta S, it is the area bounded by the curve L, and An is a unit vector normal to the surface, that is delta S. So An is the unit vector normal to the surface, delta S. So curl of a vector field is defined as such. Now we move on to the physical significance of curl. What is the physical significance of this parameter curl? Actually, the curl provides the maximum value of circulation of the vector field per unit area, and it indicates the direction along which this maximum value occurs. So see here, two cases are given, case A and case B. So here the curl at the point P is out of the page, we can say that it is out of the page. And what about curl at this point P? Here the curl will be 0. Why? Because there is no rotational vector, or we cannot define any rotation over here. So here the curl is 0, and here the curl points out of the page. So curl, it is regarded as a measure of the circulation, or how much a particular field curls around a particular point P. So that is the physical significance of curl. Now what are the important properties of curl? So the curl of a vector field is again another vector field. That is, if we find out the curl of a vector, then again we will get a vector field. Now the curl of a scalar field, that is del cross V, make no sense. Then that is, it cannot be defined. That is, curl of a scalar field cannot be defined. Now del cross A plus B, A is a vector and B is a vector, then if del cross A plus B, it is del cross A plus del cross B. Now del cross A cross B is defined as A into del dot B minus B into del dot A plus B dot del A minus A dot del B. And the next property, del cross VA, which is V del cross A plus del V cross A. Now the divergence of the curl of a vector field, it vanishes. That is del dot del cross A. Del cross A is a curl and del dot del cross A means divergence of the curl. It will be 0. Now the curl of the gradient of a scalar field, it also vanishes. That is del cross del V is also 0. So these are the important properties of curl. Now we move on to Stokes theorem. That is, in divergence we defined the divergence theorem. So similar to that, by using the parameter curl, another theorem is that is the Stokes theorem. So the theorem states that the circulation of a vector field around a closed path L is equal to the surface integral of the curl of A over the open surface S bounded by L, provided that A and del cross A are continuous on S. So what's the theorem states? The circulation of a vector field around a closed path, it will be equal to the surface integral of the curl of A over the open surface. So here it's relating surface integral and the line integral. So see here, this is a closed path L. Now the Stokes theorem, it is closed integral over L A dot dl, that is equal to integral over S del cross A dot ds. Del cross A is the curl. So the circulation of a vector field around a closed path, which is equal to the surface integral of the curl over the open surface S, and provided that A and del cross A are continuous on S. So it is a Stokes theorem. Now we move on to the proof of this theorem. So in order to prove the theorem, we have to consider that we are subdividing this particular surface into large number of cells. Okay, that is, we are dividing this particular surface into large number of cells. Now if the kth cell has surface area del sk and it is bounded by a path lk, then we can write integral, that is closed integral A dot dl, which is equal to the summation over k integral A dot dl. That is, we have k number of cells, so this particular integral, closed integral, will be equal to the summation over each cell, integral of each cell, or which can be further written as summation k integral lk A dot dl by delta sk into delta sk. So see here, this is an illustration of Stokes theorem, that is, we are subdividing a particular surface into k number of cells. So here it is clear that the sum of integrals around the each cells is the same as the line integral around the bounding curve L. That is, here we each cells are shown separately, and there will be a cancellation on every interior path. Okay, that is, here it will be cancelled with this outer cell. That is, every interior path there will be a cancellation on every interior path. So the sum of integrals, when we take the sum of each integral or all the k cells, it will be equal to same as the line integral around the bounding curve L. So that is actually the Stokes theorem states. So here, taking the limit of the RHS of this third equation, we can write that integral A dot dl is equal to integral S del cross A dot ds. That is, A dot dl integral over L A dot dl, which is equal to this particular parameter, it is del cross A. So we say that integral A dot dl is equal to integral over S del cross A dot ds. That is, we have defined this particular expression as the curl. So this will become the del cross A. Why it is so means, this is the reason, that is, if you are dividing a particular surface into k number of cells and taking the integral the line integral over each cell, there will be a cancellation on every interior path, and the sum of the integrals around LKs, it will be same as the line integral around the bounding curve L. So that's the Stokes theorem, that is closed integral over L A dot dl is equal to integral over S del cross A dot ds. So that's the curl and Stokes theorem. Hope you have understood. So please keep watching the lectures. We'll come with another topic on electromagnetics in next lecture. So please subscribe our channel for more updates. Thank you.